Hi and welcome to the course on the cloud computing, and today as part of our lectures we'll be covering virtualization in cloud computing. The key concepts that we'll be covering today would be containerization, green computing, guest operating system, type 1 and type 2 hypervisors. We'll be looking at virtualization, what is a virtual desktop and a virtual machine, and then we'll be talking about virtual private network and a virtual server. We'll be defining as what is virtualization in our learning objectives. We'll discuss about the history of virtualization. We'll describe various types of virtualization, and we'll list some of the advantages and disadvantages of virtualization. We'll try to identify applications, both well suited and not suited for virtualization, and we'll describe why companies should employ virtualization. Now, virtualization is the use of hardware and software to create a perception that one or more entities exist, although the entities in actuality are not physically present. Because we are using the resources of our host machine, like the CPU, RAM, and the hard disk would be utilized of the host machine. So the virtual machine that would be created, it would be a virtual instance of it, for which you cannot feel, you cannot touch itself. It would exist, it would work just like a virtual operating system with all the features just like you have on a physical computer. Using virtualization, we can make one or more servers appear to many, a desktop computer appear to be running on multiple operating systems simultaneously, a network connection appears to exist, or a vast amount of the disk space and the vast number of the drives can be available. So we can pool the number of hard drives, or if we have a bigger hard drive, we can allocate the kind of storage that we want to allocate for one virtual machine. Same thing goes that if you have a powerful host machine which has abundant RAM on it itself, you can distribute or create separate virtual machines, and you can allocate the resources as part of the host resources to those virtual machines. Now, cloud-based service providers makes extensive use of virtualization. In fact, most platforms as a service solutions run on virtual machines. Now, for types of virtualization, we have different categories in this one. We have server virtualization, we have desktop virtualization, we have virtual networks, and virtual storage. Server virtualization makes a server appear as many. Each virtual server may run the same or different operating system. Server virtualization provides greater CPU utilization, a small equipment and footprint, less power consumption, and support of multiple operating systems. A computer system running virtual software is called a virtual machine. So we can use different virtualization softwares which is used for virtualization, like VirtualBox, VMware Player, VMware Workstation, and if you're using Mac operating system, you can use Parallels as well. Now, with the help of this software, we can install virtually any operating system regardless what's the base operating system on your computer. For example, if you are running Windows 10 32-bit on your computer, you can create a virtual machine of 64-bit. You can even install a Linux operating system or Mac OS in a virtual environment. Now, desktop virtualization, this allows the user to switch between multiple operating systems on the same computer. Same desktop virtualization technique can be provided on operating system environment on demand. Desktop virtualization provides support for multiple operating systems, which is very convenient for software developers, testers, and help desk support staff. In addition to desktop virtualization leads to ease of computer maintenance and reduced desktop IT staff administration. So on help desk, etc., if we are testing certain operating systems before they can be applied in whether they can be deployed in the student labs, we can test them in virtual instance and check the overall functionality of the operating system, how it would perform, whether it suits our requirements or not. Further, if we need certain virtual servers, instead of setting up a physical server, we can set up a small virtual server on which we can run certain applications, and the people on the network can utilize the resources rather than dedicating a dedicated physical server on the network. Just like virtual machines, virtual server or virtual desktop, we have virtual networks and virtual storage. Now, virtual network, these create the illusion that a user is connected to a computer network or a physical network and accessing the resources through that, although no such physical connection may exist. Now, the virtual networks, and sometimes called the virtual private networks, using a virtual private network, users can connect to a network and access the network resources from any internet connected computer. Virtual networks also allow the network administrator to segment the network, making different departments such as the management, development, sales appear to have their own separate networks. It's just like we have VLANs on our switches. If we are using Cisco switches on the network, we create VLANs to segregate the traffic one from the other one. We are doing the same thing on the virtual networks, where we can segregate the traffic and we can have our own set of policies on it. For example, if we want to have a separate network for HR, separate network for payroll, separate network for IT, etc., we can easily do it just like we do it on Cisco switches. Now, virtual storage provides the users with the access to scalable and redundant physical storage, though the use of the abstract of the logical disk drives or the systems or the database interface as well. Now, for example, if you are using a computer on which you have installed Windows 10 or Windows 11, it might have a hard drive of 1 or 2 terabyte and it would be limited to that. But when we are using virtual machines, we have enough storage available. It's up to us. If, for example, we don't need 1 terabyte on our Windows 11 machine, we can only allocate 50 GB to that and we can utilize rest of the storage for something else. Since we have a bigger storage and we are giving a part of that storage to this virtual machine, we have the flexibility to anytime expand and reduce the resources utilization to our virtual machines. Now, if we are talking about history of virtual machines or virtualization, although the virtualization has been there for the past few years, it has become one of the hottest topics in computing and is now the not a new idea anymore. IBM more than 50 years ago had a virtual operating system that allowed the mainframe computers to run multiple copies of the same or the different system. Now, that helps us in setting up the virtual machines. As you can see, there are lots of known clouds in the world. For example, from Microsoft, from VMware, from Google, from Amazon. You can use the resources utilization. As we covered earlier, we can have our complete infrastructure in the cloud, where we'll be able to run our services directly from the cloud. Now, virtual memory. Now, virtual memory is not a physical memory or a RAM. Instead, virtual memory combines the RAM and the space on the connected disk. It's called a page file to create an illusion that a program is running on a vast amount of RAM before the CPU can execute the program. The program instructions and the data must reside within the RAM. Now, that's the basic functionality of a RAM, how it operates and how the CPU executes the program. The virtual memory takes advantage of the fact that not all of the program instructions or the data must be in RAM at the same time. Rather, the CPU needs only the instructions and the data which is currently working or reside in the RAM. A virtual memory operating system breaks a program instructions and data into fixed size chunks called the pages. When the CPU needs specific instructions or data, the operating system loads the corresponding page from the RAM disk, and the application would perform as you would use it on a normal computer. When the CPU no longer needs the set of instructions or the data, the operating system can move the page from the RAM to the block disk. The process of moving the pages between the RAM and the page file on the disk is called paging. Now, here you can see that we have a RAM and a disk space, and we are using a virtual memory in running a system. Now, there are some advantages of a virtual memory. A running program process appears to have unlimited memory since it is in the virtual environment. The operating system can easily manage several different programs running at the same time, keeping each program data instruction secure in its own path. The operating system can take advantage of the disk storage, which is considered less expensive than RAM, because as you know, RAM is quite expensive as compared to the storage. The disadvantage of the virtual memory is that the paging process, the process of moving the instructions between the RAM and the disk, adds overhead, mostly because the disk drivers are much slower than the RAM itself. Now, early servers were not green. It means that the blade servers are designed to fit the within the rack with the other blade servers to reduce the server physical footprint, made the server easier for cool, and reduce the server power and consumption. So instead of using 4 or 5 servers which are physically connected to the network, if we have one host on which we are running 10 virtual machines, it would save a lot of power, of course heat, network utilization, and internet resources, etc. Now this is a typical example of a blade server that we can use. In this one, you can see that there is a chassis, and then in this chassis we can connect different blade servers on this one, and then you can see that these 3 spaces, or the chassis spaces, are empty, on which we can install the servers whenever we need. So there is a scalability option in this one, that we can purchase a big chassis which has the capacity of running 8 or 10 virtual machines together. We can simply slide in a server and it would work just like the one which is being pulled out. Now once we'll remove the server, or once we'll connect it back to the machine, we don't need to connect any power cables or anything. There are connectors at the back end which would connect it to the virtual environment of it, and it would have the network connectivity, it would have the power, and it would be working just like all these other blade servers which are connected to the same chassis. So it does not have a separate network, it does not have the same the dedicated power. It would be sharing the power among the all servers which are connected to the same chassis. Now after this one, we have additional advantages of blade server. It consumes less physical space. It means that you can have more servers at a small space. We call it a footprint. Now it consumes less power, since there is one chassis which is providing power to all blades. It generates less heat and is easier to cool, since it's one chassis which is taking care of all these servers. So all the heat from these blade server is dissipated from these same chassis, which have huge fans at the back end which is cooling all servers which are connected to it. Now it's easy to install and configure, since all these chassis which we have for the servers in blade servers, like this one, it has a management module of itself which we access it through the web-based interface, and through that we control all these blades which are connected to the chassis. Now green computer means that a year ago many people made a claim that the computer, email, and other computer network would reduce the vast number of pages that we print, and many forests would be spared. Unfortunately, the less paper thing never happened, because since now we have more information available in the soft format, we have ebooks, we have PDF documents, we have even the books available in the digital format. So people who are more inclined towards reading the books in hand, they ended up printing more papers than ever before. Worse yet, the desktop, laptop, and handheld devices now touching all aspects of our 24/7. Most devices never got powered off. The result is that the computer and the device's power usage is now growing on an exponential rate. The main idea was that now, since we have virtual machines and computers which we can access remotely, there will be less utilization of power, since we'll be centrally connected to these computers. But on the contrary, now we have the tablets, we have mobile phones, we have smartwatches, which requires charging on daily basis, which is consuming more power. Because of this impact, the computers now play with respect to our environment. Many green computing initiatives have now emerged or have disappeared. Now some general guidelines of a green computing include the following: power of the devices when you are not using them, power up energy intensive devices such as laser printers, etc., rather than printing the disk using the desk jets, etc. Use notebooks when possible instead of using desktop computers, because when you are using a desktop computer, the CPU or the tower itself would consume electricity. Then you'll have a separate monitor that would require power as well, in addition to the printers and scanners that are connected to that. Now use the computer's built-in power management features to go on standby mode. For example, if a user is not using it over a period of time, it would automatically go in the sleep mode, which would save the power. Minimize the unnecessary printing and dispose of e-waste, for example, the ink cartridges, monitors, and the compliance with the government rules and regulations, etc. Now we have server virtualization. Most servers today are either very busy running a high level of CPU utilization and are idle a significant portion of the time waiting for something to do. By adding virtual machines to a server, you can utilize the unused CPU time. Since we have resources on our servers, which has, for example, Xeon processor, 32 gigs of RAM, and maybe a bigger hard drive. So instead of using it for only one application, you can create virtual machines on that one, and with the help of that we can utilize the CPU idle time for better purposes. Now here we can see server virtualization. We have a server which is server 1 and server 2, and we have a load balancer in between. So instead of sending the request individually to these servers, what a load balancer would do is that it is sitting in the middle and it's making sure that the requests are equally distributed among the servers, and then it would be sending the load or balancing the load equally. If it would see that the server number 1, server number 2 for example is busy in lots of other requests, so the next request can be transferred to the server number 1. Now in the virtual machines, that's what we were talking about, that for example if we have one dedicated host or a host machine which we are using for virtualization, in that we can create multiple virtual machines, for example Windows Server 1, Windows Server 2 and Linux operating system, etc. Let's try to understand hypervisors. You have learned the hypervisor is a software that resides beneath the operating system. There are two main primary types of hypervisors. There is type 1 hypervisor and there is type 2 hypervisor. The type 1 hypervisor sits between the hardware and the virtualized operating system. So it would be an appliance that would be installed in a rack on a data center. It would have enough RAM, CPU, and the storage that would be attached to it and would be capable of running virtual machines. Now it does not have a operating system on itself, rather it would have its own console through which we access the hypervisor to manage the virtual machines. Whereas on type 2 hypervisor, in contrast, it runs a specialized operating system that sits between the hardware and the virtual operating system. Type 2 hypervisor are the kind of hypervisors that we use on our computers. For example, if we are using VirtualBox, we are using VMware Workstation, etc. So we have an operating system on our computer. On top of that operating system, we are using VirtualBox or VMware Workstation, which would help us now to create the virtual machines. Now, since this software to create virtual machines, which is VirtualBox or VMware Workstation, is installed on your Windows 10 and 11, now you'll have to create the virtual machines using this application that you have installed. Now the advantage of type 1 hypervisor are performance and security. The performance of type 1 is far superior than type 2. The advantage of type 2 hypervisor is that it is simpler to manage and to configure. Now here in this picture, as you can see, type 1 hypervisor is a hardware. On that there will be a hypervisor which would have a web-based interface through which we can control the virtual machines which are installed on that one. Whereas type 2 hypervisor would have a hardware which is our computer. On that we'll install a software or host operating system which would be Windows 10 or Windows 11. Then we'll have the hypervisor software and other applications, and that software, which is VMware Workstation or VirtualBox, etc., would help us in creating the virtual machines. Now this is Hyper-V, which is a Windows built-in virtual machine software. You can find it in the professional version of Windows. If you are using a home edition, you cannot add it to the computer. We have the videos on our channel how to install Hyper-V. You can check it over there. Then VMware Workstation Player, it's a free version from VMware Workstation. Version 17 is the latest one. That's the free version that you can download it from their website. Then we have VirtualBox, which is another good software from Oracle which we can use in order to create different virtual machines. Now desktop virtualization is showing that we can have a virtual machine and then we can set up different virtual machines on it, which could be either Linux or Windows based. Now let's see some of the advantages of desktop virtualization. A single desktop computer can run simultaneously multiple operating systems on. The need for duplicate hardware is not required. It would consume less power. The primary disadvantage of virtual desktop is that the system incomes overhead due to the virtualization and will not be as far as identical standalone system running on a single operating system. So since now it is sharing the resources from the host machine. If host machine is busy in running different operations, you can feel some difference, or the speed would vary depending on the strength of the host machine. Now, desktop solution on demand. A new employee joins a company, for example. The IT staff in turns prepare a desktop computer which is needed with the software and deliver it to the new employee desk. When it comes in time to upgrade the software, to the IT support member carrying the CD-ROM disk would visit each desktop computer to take as long as needed to install the software on that computer individually. A high-tech data center would be required. In turn, it would have a desktop administrator to push the upgrades across the network, and it would be required to manage and support the systems on the normal duty hours. When the users encounter a problem, the IT help desk staff would again show up at every computer. It would fix the problems, and then you'll have to hire the high-tech data center, and the persons who are managing those data centers, help desk support team would be required in order to provide the support. Further, after the office hours also, you might need a remote administrators as well to gain access to the network and solve the problems of the people. Users who were frustrated with the IT staff and its processes would simply install a software on their own systems, with the company may or may not own. Worse yet, such software installations created a general organization risk, viruses and malware, etc. So instead of calling the help desk staff to fix the problems, they might install the softwares which would allow them to access these computers from home, and they'll be able to fix those problems, but that in turn brings lots of other security issues on the computers. Now, since we talked about different softwares that we use in order to virtualize the operating system on Windows platforms, we have another software over here which is Parallels Desktop for Mac operating systems, and it can be used to run virtual machines on the Mac operating systems also. Now we have virtualized operating systems. With the faster computer networks along with the migration to the cloud-based solutions, the approach to desktop management is changing. Today, many of the data centers are moving to on-demand delivery of the desktop operating system environment. In this way, when a user logs into a system, he or she would receive access to his or her system, customize the settings, assigned operating system, and needed applications would be installed. On-demand operating system is the software and the user systems which are pushed to the desktop across the network so that they can use or access the services which they have requested. Now that's an example of a virtual private network. Virtual private network is just like you are accessing your network from home. Suppose you want to access your computer outside the office hours from home. Now, in order to access the network from the normal internet connection, it's not possible since we don't have a dedicated IP for all the computers or the network. So in order to provide a safer connection, we have a VPN connection through which it would authenticate us to our network, and we'll be able to access all the resources of the computer while sitting at home. Now, the benefit of the centralized network, for example, if we have all the computers on the cloud and if we are providing the services through the cloud-based solution, is that the administrator will be able to install applications remotely on those machines without any interaction with them or without having a dedicated interaction with them, and even the personalized support can be provided to those computers. Now that's a VPN support that we configure, or we can set up a VPN connection to our computer using the settings which are available on the network. Now that's a normal local network setup that we have. Just like a normal network, we have different computers, printers, fax machine, file servers, and the computers, etc. connected to a typical LAN connection. Now, network allows the users to share resources such as printers, storage devices, and applications. Most businesses utilize the LAN to connect the users. Typically, LAN are just the cables and the wireless devices that connect to the same network using the routers and the switches that we have on the network. Now, that's a typical example of a physical network. A physical network is a network where all computers are connected and they are segregated based on their departments and their importance if they want to access the other division as well. For example, we can have a separate sales virtual network, we can have the management virtual network, we can have a development virtual network, and support virtual network, so that the computers in that network can talk to each other. If we want to allow them to access the other networks as well, that's possible. Since we are doing it all in the virtual environment, we can set up the rules and regulations as we want on the network infrastructure. Now we have data storage virtualization. Data storage in the cloud talks about the cloud-based data storage in detail. We learned the cloud data storage in the following have the following advantages. For example, it is scalable. The storage and space can be there on demand. The ability to pay as you go. Behind the scene backup and data replication. So it would keep on maintaining the backup. You don't have to worry about the backups. What are the schemes, where it's saved, and all those things. It would support the common operating systems, access from anywhere, anytime, essentially any device, provided you have an internet connection. Ease of document sharing. So using the same cloud-based services, you can easily share the documents. Cloud-based storage has the following primary disadvantages, which are that some users are still not comfortable with their data in the cloud. For example, if they are sharing their personal pictures or family pictures in the cloud, they are still not sure that if their data is 100% safe on the network or not. Cloud-based files access is slower than the local file access due to the network overhead and even the internet connection. For example, if you're traveling somewhere and you have a very slow internet connection and you want to download certain files from the cloud, it would take some time to get those files downloaded. Now that's data storage. If we have a network attached storage like a NAS device connected to our network, we can access it on the network. It's just like we have a cloud-based storage in the cloud. We can utilize the same storage. We'll have the same access rights and everything. The only difference is that the download speed on a network attached storage on a same network would be faster than sometimes if you have it in the cloud, because the speed of the data transfer from the cloud really depends on the speed of your internet that you are connected to at a specific moment of time. Now here it's very important to understand the Dockers and containers. Deploying large software applications can be a challenging process. The target systems upon which the system or the software is being installed must often have specific operating system level as well as specific library or the software installed. Traditionally, the software developers created installation programs that installed the needed software only. To simplify the software installation process, Dockers allowed the programmers to package together all the software necessary for an application to run in a package called container. So it will not have a separate dedicated operating system. It would be contained with all the required software that could run that specific application. Then the users who have the Docker installed on their system simply need to load the container in order to run the corresponding application. Since it has all the necessary programs, now you don't need any specific operating system or other applications to support your containered application which you are running through a Docker program. You can think of a Docker program as a virtualized application rather than installing a complete virtualized operating system within which the application can run. Docker instead leverages the application containers. Each Docker contains an independent and self-contained meaning, or one application that is running a container will not affect the other. The process of placing the application into a Docker container is called containerization. Access across the web is possible. Many containers with the solutions are available for use. The best thing about the Docker is that all applications are running independently to each other, so that if there is a problem in one application of a memory leak or anything, it's not going to affect the other applications which are running under the same system. Now next is that not all applications are well suited for virtualization. Despite of the performance utilization gains most applications would experience with the virtual environment, some applications are not well suited for the virtualization. For example, the application with unique hardware requirements. If an application requires unique hardware or device requirements or the drivers, etc., the virtualization software may be unable to support these kind of actions. Now the graphic intensive applications, if the application of a graphic intensive such as 3D modeling or online gaming, the virtual devices drivers may be slow or input to process these unacceptable level or unprecedented level. Now we have data storage and wiping in the cloud. Next concept is understanding data storage wiping. If you remember, we covered data storage earlier, and we learned that many facilities offer cloud-based storage. Now, often cloud-based data storage provide many users to share the storage, and many users would be accessing the same storage across multiple customers. Now, assume, for example, that you store a confidential company document within the cloud. Now, later you want to delete the document. Normally, when the file is deleted from the system, the file simply marks the location within which the file resides as available for the use and to restore the files. Now assume that another customer comes along and allocates the space on the disk for the storage, but does not write the information on that space. Now, should the customer examine the allocated space, the customer may have access to the previously deleted confidential document. To prevent this, such data which is written and deleted by a customer, data access, any cloud-based data storage facility will provide a facility of wiping the file contents or deleting or overwriting the data in a way that it is not recoverable by the other customer who is using the same storage after some time. As you can see, the previously deleted file space would have the space available on that one. But if you will properly delete it, it would remove all the traces from that, so that the other customers who are using the same storage will be able to access the services, and you will not have the thing in mind that maybe someone else will be able to access your data. Now there is another concept of distributed denial of service, where multiple computers would, or the attacking site would, attack a target computer in order to do certain operations. A denial of service attack is a hacker attack on a site, the goal of which is to consume the system resources so that the resources are not available on that one, and the system would stop working. Now there are different ways and commands in order to do that. For example, a repeated ping command to a system would put it in a loop where it would keep on sending the request, and at a certain point it would become completely irresponsive and the users will not be able to access the services which are hosted on that specific server. Further, it can be challenging for a server to defend itself against the denial of service attack. Often, a server slows down considerably before the attack can be detected and defended. The advantage of a cloud-based host with respect to denial of service attack is that the cloud server may scale its resources quickly and to respond to the attack messages in a way that the site users are not impacted. Further, it would notify the administrators on the cloud-based systems. They are using highly sophisticated intrusion detection and prevention systems for any activity which is taking place. The increased scaling will notify the administrator that the site is under attack, and they can take the immediate actions in order to tackle that problem. Now we have packet sniffing. As you know, in the internet and cloud, application communicate by exchanging the packets of data. Whether we have a wired network or a wireless, each computer examines packets and determines that which ones are addressed to which one. So if a packet travels on the network, it travels with the information that it is intended for which PC on the network, so that the right traffic is delivered to the right PC. Now a hacker can write a code which lets his or her system to examine the content of each packet that travels travels to a computer. Such programs are called the packet sniffers. For example, we can use Wireshark in order to sniff the packets on the network. It allows the hackers to view, in some cases, change the packet contents within the wireless network or a LAN network. Hacker can simply monitor and redirect the packets to the different computers where it wasn't intended to reach. Now, in order to tackle the problem of packet sniffing, etc., is to use the encrypted communication channels. The cloud, for example, because it allows the users to connect to the application from anywhere, increases the potential risk because users may connect from an insecure network or from within which a wireless traffic is being monitored. Now, to reduce the threat of such attacks, you will see that more cloud-based application requiring a secure connection in future to protect the identity online. Next is man-in-the-middle attack. The man-in-the-middle attack is much as it sounds like. In general, the attack occurs when a hacker, for example, is able to interrupt the network messages and exchange and especially place him or her in between the user and the remote system. Once the hacker is positioned in this way, messages can be sent that appear to come from either the user or the system as needed. As you can see, the attacker or the hacker has placed himself in between the user and the site. So now he can capture all the messages which are being sent from the user to the site. Rather, he can modify the messages from the site to the user and user to the site, and it becomes very difficult to get the right information, and he can take benefit of the information which is being transferred. Now next we have a hypervisor attack. But before covering the hypervisor attacks, we'll have to take care of the malicious employees on the network as well. Companies spend considerable amount of money in trying to protect their data and communication from the hackers. IT staff, for example, would deploy the firewall, encryption mechanism, monitor the network, traffic the intrusion, and much more. But the employees who are constantly trying to find some information, or sometimes they are not properly educated to protect themselves against any kind of penetrations, would be the main reason why the networks are compromised. With all of these security features in place, the most difficult challenge for the company is to defend itself against the malicious employees. Now, the developers, for example, have access to the database, and the IT members will have access to various systems and the password, which means that every system everyone will have an access to the system which is accessed by a human relation to the payroll department or the email or the content and other things. So you will have a separate username and password for each employee. By shifting the data to the cloud, you may have sensitive data away from your own employees. However, the data is now accessible to the staff and the IT personnel that you don't know. So you don't know that who is accessing it and who has full access to those things. Now, since on the cloud-based systems, the complete control and even on the network is most of the time with the IT administrator. So if those are the guys who are playing around with the data, the employees will be always afraid that the data that they are saving or the information which is saved on the storage is safe or not. For many data items such as payroll data, and the cloud-based staff is likely less interested and curious about the data. That said, companies must feel confident that the data they store within the cloud is secure. To meet these concerns, the cloud-based solution provides the identifying their recruitment and the hiring process, etc. Further, there are encryption mechanisms, like if you are saving your data in the cloud, it's your choice to choose the encryption mechanism that you want to have once your data is saved on the network. Now, in hypervisor attack, hackers refer to a process of taking over the hypervisor as hyperjacking. To understand or the underlying hardware may assign the CRC, which is cyclic redundancy check, state value to the hypervisor. Should this value change, the hardware can detect that the hypervisor has been attacked or has been replaced by using different means. Now in guest hopping attack, as you can see, if a hacker is unable to directly attack the operating system A over here, he is trying to attack one of the virtual machine which is host on a host virtualized server. The hacker may then try to attack the operating system B, which is on the same virtual machine. Now the hacker referred to an attack from the one guest operating system to another as the guest hopping. So if he will try to gain access to this machine, now he'll try to look for the other vulnerabilities on the guest operating systems which are also hosted on the same virtualized server. Now we have a Cloud Security Alliance, that's a alliance which offers training and certification in the cloud for security and knowledge. And now we are talking about the SQL injections. Now an SQL injection occurs when a malicious user inserts one or more SQL queries within one or more fields on the page. For example, if you have a login page for a username and password, and if a user would pass in a query over there, it would take the advantage of the weakness on the database and can get all the details about the users or can even drop the database. Just like here it's written that Smith it's passing the operation that dropped the database employees by just passing a command on that. Depending on how the database user uses the user input, the processing may result in the executing of the injected SQL query, which is in this case would delete the database from the company's employees. Now many cloud-based SaaS solutions and multi-tenant applications where multiple users are using the same application, which means that the different customers may share underlying resources such as database. If a SaaS application falls victim of an SQL injection, it might be possible for a user in one company can view or change or destroy the data for the other customers who are relying on the same database on that server. Now we have physical security. In disaster recovery and business continuity cloud, you'll examine the variety of system and threats that we'll be covering later. A cloud-based solution provider like a data center facility is subject to multiple threats including the fire, flood, theft, earthquakes, tornadoes, hurricane, etc. or power outage. Now most, however, will reduce the risk of such threats by replicating or co-locating the identical system to a geographical location. If you will try to set up a virtual environment on Amazon Web Services, for example, it would ask you that where you would like your infrastructure to be. For example, if you're choosing Middle East in the starting, it would ask you that what would be the secondary location where you would like to host your things. So it is creating a replica of your servers at the primary location and a secondary location. So in case if there is a problem on the primary location, they will redirect the traffic to your secondary location where your customers will not feel any difference that your primary location is not accessible, and they will be accessing it from the secondary location in order to gain the maximum access and utilization of the resources. Now, why do we virtualize? There are a variety of reasons why we virtualize. It increases the device utilization, for example, CPU utilization, where our computers were not utilizing the CPU to the fullest. Now we can utilize it for that purpose. It decreased the device footprint, so we don't have a number of devices on the network. It decreased the power consumption. Instead of running multiple machines, now we can virtualize the machines and we can save a lot of power on that. It simplified the operating system and application administration. So instead of going to individual computers, now they can simply virtualize the systems and can run multiple machines on one system. It's fairly easy to patch the systems for any updates. Device storage and other scalability problems has been resolved. It can increase the user access to the key resources, and increase the flexibility of supporting multiple operating systems, and improve the management of software and licenses. It further improved the utilization of reporting, which leads to improved capacity planning, etc. Improved the disaster recovery for the business continuity plan, And then there are some disadvantages of it as well. For example, new staff would require some training before you can use the virtualized processes. Not all applications are well suited for virtualization, and the virtualization process adds slightly overhead, which will make some application to run a bit slow on the network. So that was our chapter about virtualization. I hope things are clear. That's it for today. Thank you very much.